Oh, hey, how are you? Great to hear. Yeah, come in. Make yourself comfortable. Like a drink? Sure. There you go. Welcome to the Tech Lounge. Shall we begin? Welcome to the Tech Lounge with me, Christian Chiller. I have another interview for you from the summer. It's another interview with someone from Docker. I have had a few people from Docker over the past few months, and today is the turn of Oleg from Testcontainers, a company that when we spoke had been acquired by Docker only about 6 months before. Now we're probably coming up to about a year, actually. And it basically brings this, instead of infrastructure as code, it's kind of in the code as infrastructure world. Very interesting. It was at an event, a little bit of background noise, so the usual caveats apply, but I hope you enjoy. Before we begin, there's just a few people at the door who've got some things they want to tell you. Then we can get stuck in. If you'd rather not hear these interruptions, then please support the show. You can find details in the episode and show notes. Test containers. We don't really need to do what is Docker. I think that's pretty well covered. But what is test containers, and why the test? Like, what's the additional that you're adding to a normal container?
Right. The name is a little bit. It's a little bit too vague, maybe, and it points people towards the unfortunate decision that it's only for like a testing library or something. So test containers is a very generic thing. It's a programmatic API. There are open source libraries, and there's programmatic API that gives you the power to manage, configure, manipulate, and use containers from your code. Mm-hmm. We target pre-production use cases, so your CI pipelines and your local development environment in the inner loop. And, well, the library gives you power to manipulate containers programmatically. Okay. It gives you a number of benefits. One of them is that you can put it right in your application lifecycle, or classically in your application tests lifecycle. That's where the name comes from. But sort of the functionality it gives you is very generic. What test containers allows you to do is to define with a little bit of code which technologies you want to run, and test containers will run them for you in a Docker environment. So your application tests or your application can declare which environment it needs to run by itself. It makes your application run or your application tests run isolated, ephemeral, and repeatable, which is very, very important for tests, again, because you want to run them, something goes wrong, something goes right, you want to run them again. You never want like a stale environment to interfere in your results. So having that configuration for the environment, which dependencies your application needs, like a database or message broker or your vector databases, very important nowadays.
That's my next interview.
Or like Elasticsearch or I don't know, anything like that. Number of benefits. It never gets out of sync with the application needs. It's literally the complete copy in your CI and locally. So if something breaks, you have the full environment parity. You can fix it very, very quickly because you can reproduce it very quickly. And it doesn't depend on any third-party provisioned software for you. So you, like, all the power to create those environments and necessary things are in the hands of developers, which is great, right? Because you want those tests to be shifted as much to the left as possible. You can run your application with the very realistic-looking environment. So that means that you can run like high-level integration tests that will actually give you confidence your stuff works, rather than give you like a code coverage number that you're like, well, yeah, but I'm still not sure if I deploy that everything works. Yeah. And it's a very convenient kind of sort of declarative way to create environments, because again, it is in your code, right? It is not YAML, it is not like some sort of XML or other configuration files which are limited. You can do whatever you want in the code, and as a developer, this is literally where you're proficient. Yeah. Right?
It's a very thorough introduction, but I just wanted to clarify a couple of things just to be sure. So it's inside the code you can create the containers you need as you go. Is that
Yes.
Yeah.
So you can spin up containers from any Docker images that you want and provide additional configuration for that. So like imagine you're running Docker run expose port 8080, something, this is my application. You can do that programmatically from the code, which gives you, besides shifting it to the left, gives you also a number of benefits like abstractions, right? Which is you can create, and we have the like ecosystem of test containers modules, which are pre-configured abstractions for running particular technologies. So as an end user, as a developer, you don't need to know how to run, say, like Elasticsearch or Kafka in a container, because the configuration could be pretty thorough. You just add a library and say like new Elasticsearch container from that image, and boom, you have it. You can override the config if you want, but the defaults are very sensible for most cases.
And what's the language support at the moment, the programming language support?
So there are, I think, around 10 languages have implementations. So Java is the most mature and probably currently the most advanced as well. There is a but most of them have like this sort of the sensible baseline level. We have Golang, and it's also like very, very capable. We have maintainers on the payroll on the test containers team for that. We have Node.js, we have .NET, we have test containers Python, we have some more niche languages. We have Ruby, we have Elixir, we have Rust, we have Haskell.
The fact that Ruby is now a niche language is somewhat... Anyway.
Not niche, but like not the top 5, right? Not the top 5 languages. And then, and there is also a few implementations for test containers PHP, which are currently in the community, and we're working on figuring out which one would be sort of the best way to get under the test containers umbrella to point the community efforts and saying like, oh, look, if you're like, you don't need to reinvent it again, right? Like this is it. We don't have the PHP person on payroll currently maintaining that, but like if you want, we will help you with contributions, expanding the module ecosystem, getting it to the point that it works with the same abstractions as the others, and so on. So it's an active open source project. There is a ton of people involved. There is a lot of participation from various also technology vendors. Because people also like, we would like to give developers the best way to test against our EKS, not EKS, but like our technology, our database, right? Our quadrant or local stack, right? And they're like, we wanted to
Thank you for picking a local example. Sort of. They have an office here,
so and then we can partner with them, and we can sort of chime in together and say like, look, this module is not only test containers community says that, oh, if you want to test that, but there is also the company thinks that this implementation is good and decent and would serve your needs, and also put some engineering time on the line for making it keep up with the updates and so on.
Digging right down first, can you literally cover every kind of option you might put in a YAML file, or are there some things that you may still have to go to YAML for?
The Test Containers API offers a very comprehensive yet opinionated API surface for what the Docker client can do. We don't actually shell out to the local command, right? The Test Containers talks directly with the Docker daemon. So it's in some ways it's a little bit more powerful as well. And we offer also kind of sort of opinionated additional API in that. So for example, when you start a container, very often you want to put some files into container, like configuration, before you actually start it. And it's kind of hard to do with the command line very much. But with test containers, it's a little bit easier because we have a more refined lifecycle control with hooks.
And you could even create those files in the code, I guess.
Yes, you can create those from string. Let's say like, oh, this is my content that I want to be that needs to become the kube config, right? If you are spinning up a Kubernetes cluster with test containers. And then you can define them programmatically and say like, when the cluster, when my container is going up, I want that file to be there, and it's going to be there. And then plus for cases where you want to, we also, from most libraries, we expose the Docker client directly. So you can do also things that are not exactly idiomatic for test containers. But if you really want to do that, you can do that with an API. And sometimes this is very, very useful. For example, Docker client, you can limit the resources that you give to particular containers, which is very helpful for creating sort of the benchmarking or regression test environments because you want to limit the resources so you have the reproducible kind of sort of building block for your application. But sometimes you can also be like, oh, I want to set up the container name, which is, well, a sensible request in some scenarios, but for test containers where we create containers and then we create more containers from the same config, potentially while the previous environment is like being killed, there could be some conflicts on the name and then it will fail. We don't want that. So we try to hide that under deeper level. And we really, in test containers like project, we really try to nudge developers to do the right thing. And we want to make easy to do the right thing. And then we don't actively try to make hard to do the wrong thing, but we're trying not to advertise that for but people find those as well, and it's still come to us to the Slack channel for the support and everything.
I just want to go up to the more broad again. So I think Test Containers was a separate product at some point. So prior to that point, or still, do you also support other container runtimes, or is it now and always has just been a Docker?
So Test Containers always has required a Docker API compatible environment, which is interesting, but also like because it's the phrasing there is very precise because we do talk to the Docker daemon, right? So we need an API compatible endpoint, and we don't have any particular code pieces in the code to support other runtimes. Right, so if there are other solutions besides, for example, Docker Desktop, who are offering and say like, "Oh, look, we're exposing Docker," great, right? I didn't work with that, and it works perfectly with, for example, some other solutions like you can get Kalima on the Mac OS, right? Or you can run the mini Kubernetes thing and make it expose Docker API, and that would work modular, maybe some particular file system operations, but like so it would work, right? But we're not actively supporting other other runtimes, and we never actively supported other runtimes because the core open source team for Test Containers has always been fairly small, and there is a lot of surface that we needed to cover. Specifically, if you look at the amount of modules, so understanding how those technologies work, shaping the opinion, what is the sensible. That's a lot of work, and just adding the runtimes on top of that makes no sense. Yeah,
actually, I meant to ask this a minute ago, but digging back into the Docker side, can you also do things like Docker Compose, or what other parts of the Docker tool chain can you use Test Containers with?
Yes, so you can use Test Containers with Docker Compose, and the experience there I think varies from the particular implementations. My experience mostly in Java. And I think it works the same way in Go and I think .NET. But let's talk about Java, where I actually know perfectly things.
It's popular enough.
It's a good language for enterprises. Stable, big ecosystem, good libraries. So there is a Docker Compose module. So you can say to the Test Containers, "Oh, this is my Docker Compose file, and then please spin up environment from this." And it's a little bit less configurable than having individual modules, but we can run from the predefined things. We also can build Docker images by there's an API saying like, "Oh, I want my Docker image like this. This is my Docker file, build it from here." It will build it automatically. So it will also pull the images from Hub or from other Docker registries if you don't have them locally, of course, to reduce any friction. So those parts of the ecosystem are working very, very much in sync. There are other products that Docker have. So, for example, Docker Build Cloud, which is currently not integrated.
That's also quite new, isn't it? So,
but it's all it is a backend for efficiently building Docker images and using a lot of sharing. And there is optimizations to benefit your whole team and like when you build Docker images. But it's a little bit orthogonal use case to running containers. So there is no clear integration. And then, for example, Docker Scout is a security tool, not integrated. I think you can easily maybe do that on your project level with them if you want to. But so far, it's a little bit like it's unclear how to integrate them maybe together on the ecosystem level. Yeah. But they would not prevent usage. Test Containers will not prevent usage of either of those, and then they would work beautifully if you want. And there is also, of course, the test containers cloud, which is the...
Let's come back to that in 1 second. I want to ask one more question first. That was next on my list. Just because in this kind of, we had this infrastructure as code space, which is mostly when we talk about YAML files. There's also HashiCorp, like HCL and things like that. But there's you, and there's maybe one other product I can think of, there may be more, that does this instead in code, which is Pulumi.
Yes.
Somewhat similar.
And also Dagger.
Yeah. It's an interesting one to bring up, but that's newer. See, Pulumi has been around a little bit longer, and I guess Testcontainers is probably about the same. But it's weird in that, it feels like that should be a more natural way to do things because it's where you are. But it still feels like that this, I don't know what to call this, like code as infrastructure instead of infrastructure as code. I'm not sure. But it still feels like that's the unusual way to do things, even though it feels like it may be more obvious. Is it just because we got used to like the dev and the DevOps and we're just used to that division, or people like having the separation, or am I just wrong and maybe it's more popular than I thought?
No, I think you're right. I think YAML as the configuration options specifically for production has won. Right. Yeah. And then whether people like YAML or not, whether people have to deal with like production, like actually industrial levels of YAMLs and they hate their life for it, or whether they love working with it because it's a simple format is a separate question. I think the approaches which use actual programming languages are a little bit superior.
Yeah, it feels like it should be.
They're usually more flexible. You can very easily build abstractions. And there is also a lot of tooling that actually helps you in the particular way that it helps you with your other parts of the job, specifically if you're a developer. I think one big benefit for YAML-based configurations is that you get the whole ecosystem at once. There are no kind of sort of tension between different tribes within the larger community for accepting it. And I think this is one of the reasons why YAML actually has won. There are many formats for configuring things, right? But I think there is also natural tension for not liking things that come from other programming languages, or at least it was maybe 10 years ago when the cloud movement has started, right? So what do you have as options? XML, right? And people will be like, oh no, this is Java 2 Enterprise, I hate working with it. And the part of the community would be like, no, that's theirs, we don't want to do that. Even though there's like, maybe it's not that bad. And there is tooling for this, maybe you can do it better. And then some people will be, oh, maybe JSON. And then that's naturally the JavaScript format. And other people are like, why should JavaScript get the benefit of having the natural format? No, we are not using JSON. And then there are like closure EDN, right? Beautiful format, works perfectly. People probably were like, well, too niche and we don't like it because it's closures, right? And then I think, and YAML was no one's. And then people were like, well, it fits my needs. Like, and then small examples is also very, very workable with, right? So it's the problems are happening back when there is too much and there is no abstraction capabilities. But like, you get the whole ecosystem and no one is against that. Everyone in the same boat about that. So when you build tools that work with YAML, and that's where a lot of growth was when we sort of started building the tooling for the cloud and cloud native projects, they're like, yeah, I want the whole ecosystem. Because on the cloud parts, on the ops parts, you don't care of the actual programming language. You run containers anyhow, right? So like you don't, and you want everyone's. And eventually you, of course, like you're like, oh, would be cool if my cloud was the best cloud to run Java applications because that's a lot of workloads and a lot of money. But initially you were like, no, everyone in the same boat. So that's how YAML won. And then we also feel that problem a little bit now with test containers, for example, because here at the conference, for example, very often I ask people like, oh, are you familiar with Java? Like, what's your favorite language? Can I show you the snippets in Java? Would you hate me for it? Or would you understand the value by looking, even if you're not working specifically in this language? Or do I need to pull up a different demo for you because you are more familiar with, say, Golang or Python? So there is, even though the concepts should be easily understandable from any community, whichever you come, I think there is a little bit of tension for particular programming languages.
Yeah, makes sense. That does make sense. That's also different platforms have
maybe more used to creating environments as they go.
Yes,
as well, kind of
and
thing,
also kind of sort of with YAML, you know that all the tools in your whole loop, specifically outer loop for sure, will work with YAML, right? And then whoever is there, there will be support for YAML. If you want to standardize on, say, Pulumi, maybe, or like, say, Testcontainers, well, Testcontainers doesn't handle outer loop. But if you want a language-specific solution, you need to be sure that there is the whole support from the whole DevOps process. It's a little bit easier for us. We target the inner loop, and we know that there is the whole support. So if you standardize on the language, whichever it is, you can be like, yeah, Testcontainers is great, go. CI will work with it, local will work with it. It's going to be beautiful.
Okay, on the subject of cloud, we started talking about this, Testcontainers Cloud. I guess this is the product. I'm kind of intrigued because from what you've described so far, I'm wondering how you turn that into a product. So yeah, tell me more.
So Testcontainers requires a Docker environment. That's where it spins containers. It needs this runtime. And Testcontainers Cloud is a product. It's a paid service, and it's the tool for the platform teams to enable the superior Testcontainers experience for the whole companies at once, and also enable the rolling out of test containers into the projects naturally without hitting the roadblocks on various parts of the DevOps cycle. It gives you, so what it is, it's a software as a service platform that gives you on-demand environments that can run containers when you run test containers tests. Technically, it can also run containers, not only spin up from test containers tests, but for the test containers, it configures everything automatically, and it's really, really good for that, even though you can use it as a just sort of maybe for some other tasks. What it gives you the flexibility and scalability of the cloud. It gives you the centralized dashboards and view into what application tests and what containers, what technologies you've been running. And it gives you the easiest rollout to any CI platform or any local environment for running containers during test containers tests. It's very, very natural. You get a little proxy user space binary that doesn't require any privileges on your local machine, and it will run just as a binary file in your CI. It pretends to be a Docker environment, but when the commands come in, it spins up the environment in the cloud. So your tests run locally, but your containers are being in the cloud, which gives you a very good predictability for what the size of your CI worker needs to be, because irrelevant of what is actual test workloads, whether you run it with heavy technologies like maybe an Oracle database or a couple of Kafka clusters and then like throw in Elasticsearch, or you run your tests with just the Postgres, your internal platform can give you the small CI worker, and locally on your machine, also those containers will not be consuming and fighting for the resources of your local machine, being safely offloaded to the cloud. It really provides like out of the box, very, very good experience for test containers tests.
Okay. And how does it fit into the other kind of current cloud SaaS offerings from Docker? Does it cross over with Build Cloud or or does it show up in Docker Desktop? Like, what are the entry and exit points in the rest of the kind of commercial Docker ecosystem?
Test Containers Cloud was developed by Atomic Jar, which was the startup maintaining test containers. It was acquired by Docker in December, and now it's a part of
last year.
Yes, December last year. No. Yes, December 2023. So now it's being integrated in the portfolio of the tools. It's usable. It still works. You can consume it and run it, and there are customers who are doing that at scale. It's a separate implementation from the Build Cloud. The teams have been integrated closer together. So some technical implementations might kind of be integrated together for the Build Cloud, but it's a little bit different use case. And Build Cloud, for example, focuses very much on caching the particular layers of the images and keeping them for longer periods of times, because you want to rely on that when you build consequent images. And then Test Containers Cloud focuses initially on the very sort of ephemeral, kind of sort of short-lived environments when you run the tests. If your tests quickly go down, you want to shut down it quickly as well in a very like sort of serverless manner. So there is integration happening, but it's not realized yet into anything public, I think. And also the same is, I think, true with the Docker desktop. still, I think the best way to use Testcontainers Cloud is the Testcontainers desktop application that was a separate user that user space binary for your local environments, and then the integration work to get that into the desktop is also underway, and hopefully sooner rather than later it's going to be a checkbox or some sort of configuration option in Docker desktop.
Yeah. So in this part of Testcontainers life, it's relatively new, 6 months basically. In addition to integrations and kind of the integration that'll do, is there anything else on the roadmap that you can talk about that is new, new functionality, new features, that not just the better connections? It can be no. The answer can be no.
Yes, I know that answer can be. There is no... Testcontainers is I won't say perfect library, perfect solution. It has a use case, right? And it's really, really good at that use case. And it always can be better, and there always could be optimizations, but there are no fundamentally new things currently in development. They're still open source. There are still people maintaining them. It's quite a bit of effort. We are trying to now, with the larger Docker brand, to kind of rally the community behind maybe some other implementations a little bit more, saying that, look, Docker thinks this is a great thing in other languages as well. We are now also closer working with the runtime systems, the runtime teams at Docker. So there could be potentially better integrations or some performance optimizations for specifically Testcontainers-like workloads where containers come up and down. But it's sort of the under the hood work that it's not very shiny or it's not a new functionality.
Yeah.
Right? So
I can imagine, because you have the existing APIs from the Docker products, as long as you kind of make it possible to access those through Testcontainers, you're fulfilling the need, the use case. So
Yes. And then there is a large user base we are trying to grow with. There is very interestingly a lot of growth happening recently in the usage of Testcontainers.net. Which historically wasn't one of the top Testcontainers used languages, but recently there is more and more. I think this is a very good testament to sort of how united the ecosystem is for .NET. When somebody starts saying like, "Oh, this is great," right, and very quickly other parts of the community are like, "Oh, yeah, this is actually very, very good. Let me also use it." So we see that the growth there quite a bit. Yeah, unfortunately, I don't think I can name a few Testcontainers new and upcoming features.
I wasn't expecting you to, but you never know. It's worth asking. This is it. Cool. And just final question: if people are interested in trying this out, then I guess the open source version is still there. What's the developer experience to get started? Like add a dependency or something? Is that
yes? I'll answer that. Then we'll come back to the previous one because actually there is a thing that I want to talk about a little bit, right? So yes, the developer experience getting started with Testcontainers is very, very straightforward. Those are libraries in your programming language. So you add a dependency to your project, you get the primitives for that. You can start working with the lower level sort of generic container-based primitives and declare which images you want to run in particular containers. Or you can also add the particular libraries for the modules and say, give me Testcontainers core and Testcontainers Kafka implementation, and boom, you have a new Kafka container API available for you, and you can run it, and you just need to plug it into your tests. And also, depending on the application, depending on the language and application frameworks that you're using, there might be tighter integrations between those. Like Spring Boot has very good integration with Testcontainers. Quarkus has extremely pleasant integration with Testcontainers.
You definitely come from the Java world, don't you?
And the Testcontainers Java library is also the most mature, and I think it got popular earlier than others. So it had more time to figure out that it's not to get less distracted by the test part of the Testcontainers and figure out that this is a just generic solution for programmatically interacting with containers and start building sort of like dev services like approaches for where you run your application locally and it just creates the environment for you and you get this clone and run experience out of the box.
Yeah.
So for some things, you don't even need to know that you're using test containers, and you can just run your applications, and you will be using test containers.
Yeah.
But you can also easily replicate that in your code with just a little bit of code.
Yeah.
And coming back to like sort of a very interesting development, which is you were asking about the future, right? The next months that threw me away. One of the very large parts of what we built in the test containers ecosystem, specifically in the last half a year, was of course the integration with AI technologies.
Oh, of course.
You can't spell test containers without AI. It's right there in the container. And yeah, so we heavily expanded recently the support for all kinds of vector database that you can run with test containers. There are now possibilities to run things like a llama in the container, which means that you can, like, if you are building your AI applications if you're building your applications and you want to add some AI components for part of a functionality, you can treat those very often the same way you are treating your other external dependencies like databases or message brokers. You can put your llama with your model in the container. You can run like some open source or openly available, at least models, like, I don't know, like Gamma by Google or Llama or Mistral models, right? And then you put it in the Llama and it's served locally from a container. You can give it access to G and build your little RAG environment as well with a vector database. You can spin up all those environments with test containers and kind of sort of, I think it can be a very, very nice way to enable working with AI components, but within your familiar DevOps loop, because, well, it's scar tissue, right? Yeah. We developed it not because we were like, it would be cool to have devs and ops work together.
The model ops and ML ops stuff is still open.
But it's also very important, right? But like if the commoditization of AI will continue, right, and developers will start building more and more with AI components by themselves, they will not be expert at ML ops, right? Overnight, eventually. Well, maybe eventually, but like not overnight. So bringing the AI components into the normal workflows within the DevOps pipeline, I think this is a very important initiative.
Makes a lot of sense. Yeah.
So cool. We looked at that in the last half.
I'll have a look at that. I have been messing around with the Gen AI stack that Docker has a little bit recently, so I'll have a look at yours too.
Yes. Thank you.
Cool. Awesome. Thank you very much for your time.
Thank you.
So that was it. That was our guest today. Thank you very much for joining me in the Tech Lounge. I have been Christian Scheller. If you want to know more about Tech Lounge, head on over to christianscheller.com, or please tell your friends about us. It's quiet and cozy in here, but the more listeners, the merrier. You can find more at christianscheller.com/podcast, or in the show notes or episode notes, wherever you found this podcast. Thank you very much for joining me, and you're most welcome next time.